Good afternoon, everyone. My name is Hannah Frizee, and I'm a programming librarian here at Cary Memorial Library. Before we begin, I want to take a moment to thank the Friends of the Cary Library for sponsoring this program. Their support is what allows us to run wonderful programs like the one that we will be having today with Bill. And now I'd like to introduce our guest. Bill Gette is the former sanctuary director at the Joppa Flats Education Center in Newburyport, Massachusetts. A skilled teacher and field trip leader, he has been leading domestic and international natural history expeditions since 1986. He has led very successful programs throughout the United States and to all 7 continents. Please join me in welcoming Bill Gette.
Well, thank you very much. Really appreciate it. Good to be with you this afternoon. Well, today is Our Amazing Birds. I started bird watching in 1961, so I've been at this for a while. And I think many people get started with bird watching because they're the beauty of seeing the beauty of the birds. Then after a time, birding for a while, then you really start noticing the behavior of birds. And this is a major theme of our discussion this afternoon, Our Amazing Birds. And in terms of diversity, there are about 11,000 species of birds in the world, some of them in very significantly small numbers, others very, very common. And birds differ in terms of their size, their body shape, their bill shape, their feeding ecology, habitat preferences, breeding ecology, and migration patterns. Some birds don't migrate, some migrate extraordinarily long distance, as you'll see later on. And birds, of course, they can fly, they can swim, they can run, just everything going on. And our martyred birds are dinosaurs. And modern birds evolved from theropod dinosaurs about 150 million years ago. So if you have kids or grandkids and you see a bird, you can say, "Oh, look at the dinosaur," because they are in fact dinosaurs. The only animals in the world ever to have feathers are dinosaurs and birds. So that's it. And so during the talk today, we'll discuss the many very different differences in physical and behavioral characteristics that really make birds and bird watching so much fun. A starting point for birds is the difference between altricial and precocial birds. So basically, the two major divides here. Now, altricial birds are when they think of robins and chickadees and things of that, crows and things like that. The newly hatched birds are relatively immobile. They generally cannot leave the nest. They can barely hold their heads up sometime. Most of them have no down at all. And they can't get food on their own. They're totally dependent on their parents for, intensive care. And so again, songbirds and hawks and egrets and owls. And some examples here on the left-hand side are great egrets. Okay, not until they're ready to fly, until they're much bigger, will those egrets, they have to stay on that nest. And then in terms of great horned owl on the right-hand side, there's an adult bird in the back and a young one in the foreground of my image here. The other are precocial one, and these are newly hatched birds within a couple hours, maybe a couple hours after hatching out of the egg, they become relatively mobile. They can move around under the protection of their parents, and they can forage on their own for food. Now, very often the adult birds will catch something, a small insect or something, and drop it in front of their young one, so the young one gets used to, oh, there's some food, and pick it up. But these things are waterfowl, and so on the left-hand side here is the image of a willet. It breeds in throughout New England, along the coast in particular. This is a photograph I took on the Parker River National Wildlife Refuge. And notice there are 3 young ones. They're probably 2 or 3 hours old when I photographed this, but here they are running around in the company of an adult looking for food, for typically small insects in that group. And then on the right-hand side, that's a common goldeneye, a female common goldeneye. Photographed this in Manitoba, Canada. And I think she has 13 young ones there. So again, within hours after the hatch, they're in the water swimming after mama, and can eat algae and things like that at the top of the pool. So there are two ways of thinking of birds like that. I spent quite a bit of time on avian feeding techniques. Again, the diversity of the objective of a bird is to get nutrients into its body. Now, the question is, how can you do it? And that's the whole point is There are so many different ways, so many feeding techniques that birds demonstrate. Two examples, very different birds. One is the oilbird on the left-hand side, and then the black skimmer. So, so here's the oilbird. This is a photograph I took in Trinidad. These birds are in Trinidad on the north coast of South America. They're not very common. They are night hunting. They're nocturnal hunting birds. They eat fruit, and they fly around. This is in a cave, small cave, and what they do is they fly around and they use echolocation like a bat does in order to navigate and also to find the fruit trees on which they feed. So. We have owls and we have bats, and here's one that is a bird that use echolocation. Okay, then another technique. Happens to be a brown pelican, and it feeds by diving headfirst into the water. They fly over body water. Think of being in the Florida Gulf Coast or something like that, and they're flying overhead. They're looking down into the water. They see a fish and they dive headfirst into the water, like here, flying over headfirst dive into the water. And if you look carefully, you can see that there is a fish in the pouch of this pelican. So the pelican dives in headfirst, takes a huge mouthful of water in that bill and pouch, and then squeezes the water out, leaving the fish behind. So that's one technique. Okay? Other headfirst divers are kingfishers. And if you go to the Galapagos Islands, boobies, or if you were to go along the maritime provinces of Canada, you'd see northern gannets. They fly over and dive headfirst into the water after fish. Ospreys, you can catch fish, well, with your feet. Uh, Now, ospreys were in real trouble. When I was back in 1961, I was working along the coast of Maine, and the numbers of bald eagles and ospreys were pitifully low because of DDT. DDT was just really messing up the eggshells, such that the eggshells were either too brittle and they would break when the female would try to turn them over to incubate them, or they would be too thick and the embryo would suffocate inside the egg. The eggs have tiny little pores that let oxygen flow in and out of the eggshell. If you close up all those little pores, then the embryo dies. But here's images of these. I took these photographs on the estuary behind the Plum Island, with Parker River National Wildlife Refuges. Notice the size of that nest. Really, they'll use these nests. The same pair will use the same nest year after year. Okay? Another feeding technique is you sit on the water and then you dive down, like this Atlantic puffin. And they sort of start their dive headfirst into the water, and then they use their wings and their feet. Notice the feet are really way back on towards the back of the body, which is really the really best place to put your propellers, which in fact are your feet. So they dive down. And other ones that are doing surface diving, the male harlequin duck that you see on the left-hand side. This is an image from Cape Ann in Massachusetts, Gloucester and Rockport. They feed, you don't see them along sandy beaches or things like that. They're on rocky coastlines, and they dive down and they're gleaning bivalves and things like that off the rocks. And on the right-hand side is a common loon, excuse me, and it's non-breeding plumage. Now it has a crab. Now, for that loon to be able to swallow that crab, it has to pull the legs off. So you'll see, just like it's doing, it's yanking one leg off, and then when it gets all the legs off, it can swallow the rest of the animal whole. I was very fortunate. I was in Rockport, Massachusetts, and they have a jetty that you can walk out on. And I saw this white-winged scoter on the surface and then dove under the water, and it's probing with its bill into the mud, and it comes up with this razor clam. They swallow the razor clam and other bivalves whole, and then they have a very strong part of the stomach called the gizzard that it crushes the shell. The bird, then digests the meat value out of the shell and regurgitates or defecates what's left of the shell. Okay, hovering. See, ospreys hover, bald eagles. A lot of people don't really think of bald eagles hovering, but they have a really wonderful technique. And if you come along the Merrimack River here in Newburyport or West Newbury, um, you can see bald eagles at this time of year. And what they'll do is an eagle will sit up in a tree very often and overlooking the lake or over a river and just be watching the ducks and things like that in the water. And they're being very careful. And they eagles are noticing the pattern. Okay, the duck dives down here and is down for a certain amount of time, and then that comes to the surface again. And the eagle keeps watching that until it says, I know the pattern. Okay. And so when it figures out a pattern, as soon as that duck dives down, the eagle will come down over the where the expects the duck to come up and hovers over there. The duck comes up for air and bang, the eagle will fly away with it. They'll also hover over schools of fish to get one. Yeah. Okay. Other hovering birds that hover, this bird on the left-hand side is a bird that we get here only in the winter. This is rough-legged hawk. It's a hawk of the tundra of northern Canada and Alaska. Okay. And they have to hover because they're basically in the tundra. There aren't any trees to sit in, like a red-tailed hawk would or an eagle. And so they face into the wind and they hover. Notice I have this little yellow arrow. That is the alula. Okay. It's their thumb. Okay. So what happens is just, okay, you're flying back from Dallas, Texas into Boston or to wherever you are. And the pilot comes on and she says, well, we're going to be landing in the next 20 minutes. Put on your seatbelt and all that. And then if you're watching, as the plane starts coming down, they extend the wing flaps in order to give more lift at slower speeds. Well, that's what that Alula is doing. It's providing additional lift for this bird to hover. Okay. And other ones, terns, hover over schools of fish and dive in head first. American kestrels that you see on the right do the same thing. They'll sit up in a tree, watching for small birds, large insects, snakes, worms, things of that nature. And very often you'll see them over fields, just hovering, and then they'll dive down. So all different methods of how do I get to food. Okay, well, these are pursuit hunters. These are the accipiters. So we have um, sharp-shinned hawk, Cooper's hawk, are two of the examples. Happens to be Cooper's hawk. And what they do, they are pursuit hunters. Most accipiters are pursuit hunters of forest edges or inside forests. And they have a relatively long tail, which acts as a rudder so they can fly in among the trees. They're incredibly maneuverable. And so I had a group out on a bird watching trip. This happens to be the parking lot number one at the Parker River National Wildlife Refuge. And the bird that you see in the talons of that Cooper's hawk is a starling. The starling flew right in front of us being chased by this Cooper's hawk. And the starling landed on the top of the fence post that you see to the right of my image there. And it flew to the base of that fence post. And the Cooper's hawk landed at the top of that fence post. Now, if the starling had just stayed there, it might have been okay, but it tried to get away, and you can see how far away it got away from the fence post. So that's Cooper's hawk on the right-hand side is a young sharp-shinned hawk. Okay, we saw the feeding behavior of the brown pelican, where it goes and dives head first. These white pelicans, these are huge birds. They have a 9-foot wingspan, okay, and they are a cooperative feeder. They act as a team. This happens to be a photograph I took in Manitoba, and this is a photograph in Florida. So notice all the pelicans. This is a pond. What they do, they move together across a pond or across the river, pushing the fishes into shallower and shallower water. And then the pelicans are all there to grab the fish. So they are cooperative, working together to catch fish. The bird on the left-hand side of the image is a great egret, and the one in the background above the pelicans is a wood stork. So cooperative feeders. Okay, here it is in Manitoba. In this case, they're hunting in a stream. They get together as a big group. They sort of corral the fishes, move them into shallower and shallower water where the fishes are easy to catch. Okay, some birds herd things together. They walk through a field and they herd things in front of themselves. This happens to be a cattle egret that I photographed in Cuba. And this is an incredible bird. This is a bird that originated in Africa. And what happened, it was first recorded in South America in 1877. Nobody knows how exactly it got here, but probably they got here by flying. Maybe in a big windstorm, it picked them up and carried them across the South Atlantic, which happens. And it was first recorded in New England in 1952. Now they breed here, they breed in Maine, and they work around open fields like this. They'll work together, working through a field. And as one egret will walk, it might scare up a cricket or a leafhopper or a grasshopper, fly around where the other one can grab it. So cooperative feeding is quite a common behavior among birds. This beautiful bird, we won't be seeing these until the 1st of May again. This is eastern kingbird. And notice the top of the head, that yellow, it looks like it has a little crown on it. And what they do, it's called sally feeding. They'll sit up on a branch, prominent branch, usually wide out in the open where they're really easy to see. And then they'll fly from it, they'll see an insect, they'll fly out, grab it, the insect, and come back to the same perch. And they'll do that numerous times. Yeah, it's calling sallying out is coming back. And then after doing that for a little while, it might move to another perch and do it again. Okay. Some other birds that do, if you go to Costa Rica or Panama, kiskadee. It gets its name because its call is kiskadee, dee dee, kiskadee. So now obviously very, very alert. You're looking for insects to go out, grab, and come on back. And the right-hand side is a willow flycatcher. This is from New Hampshire. In this case, it's just singing. Okay. Well, you can chase things too. That's another way. This is the reddish egret. It's resident of the salt marshes and brackish waters of the Florida and Gulf Coast, Texas Gulf Coast too, like that. And their behavior is basically to run through shallow water, chasing little schools of fish. So it comes in two color morphs. They interbreed with each other. On the right hand side is the light or white morph. But notice the bill. Notice the tip is black and the base is pink. Same on the one on the left-hand side. So you have two different color morphs, the dark morph on the left, and this is how they feed. Catches a lot of fish. Okay. Well, there are other chase feeders which you might be very much more familiar with. And if you go to the beach um, in the spring or in the late summer or fall, is these are sanderlings. These are wave chasers. What happens is, as a wave comes in up on a sandy beach, for example, the wave energy is a lot enough to carry debris, sand, shells, things like that, and also any of the marine organisms in the water up onto the beach. But as the wave comes up the beach, it loses energy, and then as the wave recedes, it doesn't have enough energy to pull those things back down again. So what these birds will do, they will chase. As the wave comes up, the birds run up the beach, and the wave goes out. They run after the wave, picking up anything that the wave has left behind. Talk about some of these tough birds. This is sandwing. The one on the left is in its alternate or breeding plumage. Okay, that's what you'd see in May. They don't breed here. They breed much further north, but we see them migrating through here occasionally. And on the right-hand side, here is one. This was in January. The temperature was about 4 degrees, and here is this bird looking for marine organism in among the ice. We saw the reddish egret just a moment ago doing its dance. This is called canopy feeding or umbrella feeding. And what they'll do is, as right here, this bird will, and there are a number of species that also do this in Africa. What they'll do is they'll bird will put the wings up like this, as you're seeing in this photograph. And what that does, it does two things. The fishes that in pond are looking for shelter because they're exposed in these open pools. Well, they see shadows, and it looks like maybe an overhanging branch or something, and maybe there's some protection in the shades. So they fishes will by themselves swim underneath in the water underneath that wing. Well, okay, so the egret has attracted the fishes to them, and then that umbrella, that wing, actually shades the water from glare, and it's much easier for the bird to see the fish in the water. So as the wing that pattern both attracts the fish and also makes it easier for the bird to see the fish. Black skimmer, this is in the same familiarity along with terns and gulls. This is really a quite common bird along the southern Atlantic coast, and we get them out on Cape Cod, for example. Okay, and they feed during the day and night, and they what they do is they fly very, very low over the water. I mean, a couple inches. They have very shallow wing beats when they fly. Notice the lower part of the bill is long, significantly longer than the top. So what they do when they fly along, dragging that lower mandible just barely through the below the surface of the water. And when that bill hits a fish, they close their bill. Really pretty nice, right? Okay, then another technique, kleptoparasitism. Okay, if you don't catch them on your own, why don't you steal it from somebody? And kleptoparasitism is really common throughout the animal kingdom. Insects do it, birds do it, mammals do it. Okay? And some of them are specialists at kleptoparasitism, things like frigate birds and Jaeger. This is a male, magnificent frigate bird from the Galapagos Islands. Okay? Here are two of the Pomeranian Jaeger from Nome, Alaska on the left-hand side, and the great skua from the Western Islands of Iceland. These are two characteristics too. Well, what happens if I go back to these skuas and the Pomeranian Jaeger? If a gull or a tern has captured a fish, and these Jaegers see it, for example, the Pomeranian Jaeger, if they see it, the Pomeranian Jaeger will chase after that gull or after that tern, and sometimes grab the end of the other bird's wing or its tail or something, forcing that bird to give up its fish. And then when the let's say the gull gives up the fish, then the Jaeger will fly down and capture the fish that the other bird has left. But then we have birds like this is great blue heron. Took this photograph along the Merrimack River in Newburyport, basically the Newburyport. So in the image number one in the upper left-hand corner, notice these are two common mergansers. The two male common mergansers in the right portion of slide number one. What happens is one of those mergansers had caught a fish, and the other merganser is trying to steal it. Okay, so there's some kleptoparasitism attempted going on. In slide number two, the great blue heron says, "Oh, no, no, no." So one of the common mergansers goes away, and the great blue heron goes after the other one with the fish. It grabs the fish from the merganser and flies away. Okay, okay, lots of birds come get nectar, like hummingbirds, come to get nectar at blossoms and pollen. It's really, really important, high energy food. And this is a slaty flower piercer from the mountain highland habitats of Costa Rica and western parts of Panama. And what it does, it cheats. Okay. Instead of going into the blossom from the front where it will get some pollen on it, and that pollen then if it goes to another blossom, it deposits the pollen from one flower into the other. I mean, that's sort of the deal. The flowers are looking very, very beautiful and smelling really beautiful in order to attract insects and birds to come collect some of their pollen so it can be deposited someplace else. Well, these birds cheat. Okay, notice the hooked bill on this slaty flower piercer. And in the right-hand image is a female. So instead of going into this flower through the open end, it's going to the base of the flower to pierce a hole in the bottom of that flower so the bird can get to the nectar and some pollen. So different techniques. Okay, then we have birds that hunt at nighttime and nocturnal insectivores. This is a common potu. This is Central and South America. They're nocturnal. They feed only at night. They only use the ambient light that the moon gives them, and sometimes there is no moon. And what they have, and during the daytime, they roost like this. They find a branch or stump or something that resembles them in plumage coloration, and they just sit there all day. Now, how do they do this? Well, how do they hunt at nighttime? Well, a lot of mammals also have this characteristic. Notice the light comes in through the pupil and from the left, goes back and hits the retina on the back. The light continues through the retina till what's referred to as the tapetum lucidum. That tapetum lucidum, think of it as a mirror. So as that light comes through the retina, it goes by, hits this mirror, and it comes back again. So actually what's happening is the bird is actually seeing that same light twice. Okay. And this is the bird. Look at the bill, tiny little bill, but it has a tiny little bill, but a gigantic mouth. Okay. This is common potu. And this is what it looks like at night. So if you go on a natural history field trip to Costa Rica, Panama, places like that, if they have a good program, they'll take you out at night with a big light and they'll shine the light around. And this is a common potu. And notice the yellow eye shine. They'll also, hopefully, they'll shine the light up in trees to look for kinkajous and other arboreal mammals, and you'll get that same eye shine. Well, hey, if you don't like any of those feeding techniques, why don't you become a stream walker? Okay. So this is an American dipper. This is an adult American dipper. And what they do is this is from Central America all the way up into Alaska. I photographed this in Alaska, on the Kenai Peninsula. And they basically walk into the water, underneath the water, and they're feeding on insect larvae, fish, eggs, insects, things of that nature. And this is a young one. Notice the feathery feathers. Notice the base of the bill on this bird. Okay, it's gray. And look at this one. You see the yellow that goes almost underneath the eye? That's very important because the adult birds know that when they see yellow, that's where they put the food. So this bird, when it's approached by an adult, opens its mouth really wide, whether it's in the nest or here sitting on a rock, and the adults see all that yellow, and that's where they put the food. That's all called the gape. Yeah. Petrels. Okay. Petrels are small birds, some of them only the size smaller than a robin, spend their entire lives out on the ocean except when breeding. Um, so this is storm petrels. In this is an example of an Elliott's storm petrel from the Galapagos Islands. Notice it's a very, very calm day, no waves. And what this bird is doing, it's facing into the wind. Notice its wings are up, just a gentle breeze, but having its wings up like that is like flying like a kite. And then notice its feet. It's pushing along the water with its feet. And so the early sailors saw these extraordinary tiny little birds way out in the ocean, and these birds reminded them of St. Peter because Peter walked on water. And so this was where the name petrel comes from. Okay. Okay, descent climbing. Well, you think most birds climb up trees. They go from the bottom, they climb up the tree. Well, nuthatches have a special adaptation. The hind toe is called a hallux. And it has a long hind toe with a hook, with a nail on it, hook on the end of it. And that gives them the ability to walk down trees. Well, why would you want to do that? Well, most of the other birds are moving up the tree. You know? So if you can come down the tree instead when you're feeding, you can see insect larvae and insects and things of that nature that the birds moving up the tree won't be able to see. Okay. Nuthatches, other nuthatches, the pygmy nuthatch from the western Colorado in this case, western nuthatch. And well, okay, if Coming up the tree is not satisfactory, or going down the tree isn't satisfactory. How about we go around the tree in a circle, like a spiral staircase? So these brown creepers, North America, Southern Canada, way down into Middle America, what they'll do is they fly to the bottom of a tree, and then they'll go around the tree in a circular way, like again, spiral staircase. They get up to the top of the tree or to where it's not being productive anymore. They fly to the base of another tree and go around again in a circle. So in one case, little birds are finding things going up. Birds coming down the tree are going to find things that the birds going up the tree didn't see. And the creepers going around in a circle that will be finding things that both the other birds didn't see. One of the most exciting things about going into the New World tropics is seeing an army ant swarm. Uh, and there's a whole group, 230 species of birds in Central and South America that are associated with army ant swarms. Okay. And these birds are known for following these swarms of army ants. Here is a swarm of army ants that I photographed in Belize. Now, you can have swarms of hundreds of thousands into the millions, and they just go as a mass, as a column, through the floor of the forest. As you can see, just hundreds and hundreds of these, looking for anything, any insect larvae, any grasshoppers, crickets, small birds, tarantulas, whatever's, and when they find a prey, they just descend upon it and rip it apart, which you see right here. Looks like some kind of a cricket or something that was overwhelmed by these army ants. And then they rip it apart and take some of it back to the rest of the colony called a bivouac, where some of the other army ants are. So if you're an insect and you hear or see an army ant swarm coming, you want to try to get it. So if you're a lacewing or a grasshopper or anything, you want to try to escape from this army ant swarm. And there's a whole group of birds, these army ant swarm followers, that feed right along the edges, outer edges of the army ant swarm, capturing the insects they're trying to flee away. So the bicolor antbird, now these are usually these antbirds are really tough to see, and they're really quite difficult to photograph because they're usually in really dark places on the forest floor, in the tropical and subtropical woodlands. So these are two of them, and two more spotted antbird, really handsome. But notice they have really big eyes to the side of the head because, again, it's pretty shaded. And then we have a group of tanagers that also do this. This is gray-headed tanager from Belize. So army ant swarm. Okay, so the point being is the objective is to get food into the system, into your system. Well, how do you do it? Well, a plunge dive or a herd or a hover or a fall ants, whatever. So many different ways. Now, in terms of feeding techniques, birds are really amazing because they can see into ultraviolet light. Human eyesight is really pretty pathetic. No, I mean, we like our eyesight, but compared to other animals, it's really pathetic because birds can see a much broader spectrum of light. They have four sets of cone photoreceptors in their eyes. We only have three. Um, and the lenses of the bird's eye are transparent, which allows in ultraviolet light. We get some protection in the lenses of our eyes. And what's the point? Okay, they can see ultraviolet light. Well, many insects, fruit, the urine of mammals reflect ultraviolet light. So well, we might see a caterpillar being green on a green leaf. Okay, that's all we can see. But the birds will be able to see a green leaf with sort of this maybe yellowish colored thing on it from the ultraviolet light. So a lot of birds that do it, yellow warbler, I'm looking forward to the first week of May when they start coming back to Massachusetts. Solitary vireo. Red-tailed hawk, you can imagine if you're in a woodland or in an open field, as the case typically of a red-tailed hawk, if a small mammal has been going through the grasses, it urinates, and so leaves some trails of urine which the birds can see. Well, you can We can do hunting by smell. Happens to be a turkey vulture, a very common bird through, especially in the southeastern United States. They're just everywhere, but they've become very common in New England now also. And they have really very large olfactory bulbs in their brains, which helps them smell. There's a statistic which is amazing. Albatrosses can smell food up to 12 miles away. Okay? So here are albatrosses. This is from the Falklands, or if you're in Argentine, these are the Malvina Islands. Okay, and albatross. You know. One thing about smell, if you do a pelagic bird trip, in other words, a bird trip that goes out in the ocean looking for storm petrels and shearwaters and things like that, very often the field trip leaders will have a huge bag of popcorn. And then they'll have a couple bottles of cod liver oil or something. And at the right time, they'll dump the cod liver oil into this big bag of popcorn and mix it all up and start throwing some of it overboard. And I've been on trips like that where we haven't seen a petrel or shearwater anywhere. And they start putting this over the side of the boat. And within a relatively short 10 or 15 minutes, all of a sudden you start seeing shearwaters and storm petrels coming. Okay. Well, how about some beak adaptations? You know, okay, lots of different techniques of feeding, but what's the hardware that's being used? So here is a crossbill. These are, happens to be a male red crossbill. Photographed this in at the Salisbury Beach State Reservation. Notice the bill overlaps with each other. Mhm. And the idea is what they do is the bird will go up into a cone. Okay. It places the tip of the lower mandible against the cone, and using the top portion will lift up the scale. The cones have scales, and underneath those scales are where the seeds are. So by putting the bill there and using it like that, it lifts up the scale so you can stick your tongue in and pull out the seed. Beautiful left hand side is a female red crossbill. Notice on the white-winged crossbill, the one on the right, a red crossbill, I beg your pardon. Notice how that bill is shaped. Okay. So in the upper right-hand image, the bird has just put his bill between the cones, the scales of that cone, lifted them up, and it's feeding on a seed. It's another thing, if you a good way to look for worms and bivalves and things like, they're in the mud. Okay, they're in the sand of a beach or the mud of a estuary or something like that. There are there are a number of species of shorebirds like snipes and woodcocks and curlews and godwits that can actually open up just the tip of the bill. Think about sticking your hand down into the mud and then trying to open your entire fingers to grab something. No, but if you can just open the very tip, you can stick your bill in, and the tip of your bill, think of it as your nose and your tongue at the same time. They can smell and they can taste anything that's down in there. And when they probe their bill down and they smell or sense say a bivalve, they can open just the tip of the bill, grab it and pull it out. And here's an example. Okay. This is called distal renconkinesis. Okay. Distal meaning away, rencon being your nose, or like a rhinoceros, or kinesis, it can move. So instead of trying to put your whole bill down there and try to open it, which is practically impossible, all you can do is just open the very tip of your bill and grab onto something. Okay? So these some of the other birds, the woodcocks. Boy, it's not going to be very much longer. I mean, by the middle of March, if the snow ever goes away, the woodcocks, the male woodcocks, are going to be start singing. Okay, and that's always wonderful. If you live in Lexington, is it Dumbback Meadow? I mean, they have them out there. It's a really lovely place. Well, another way to do it is just take a big mouthful of water and strain out what you're getting, what's in the water. This is a flamingo from the Galapagos Islands, but we have them through the New World tropics. Okay, lots of flamingos of different species in Africa, and so what they do is notice the strange way of feeding. They put their belly in upside down. Okay, and what they do is they take a mouthful of water and then they push that water out, as you can see the bubbles, coming up here, and the serrations of the bill filter out the water goes out, but any of the brine shrimp and things like that that are in that water column are left in the mouth. Just, just like a baleen whale does. Okay? So other strain birds that do that, the shovelers, the male on the left and the female on the right. Okay, tube noses. Okay. I was in the Galapagos Islands, and I noticed that in one of the pangas or zodiacs that we go ashore in was this storm petrel. It had flown along and somehow had just gotten into the panga but it was so close to the wall it couldn't fly out. So I asked one of the staff members if they would be kind enough to go get it so I could photograph it. And this ocean wandering bird. Notice the tube on top of its bill. Okay, that tube, at the base of the tube are glands that filter out salt out of their blood. So if you're a species of bird, a species of bird that's always out of the ocean, the only time you come to land is when you're breeding. You need to try to keep the salt in your blood at a proper balance. And that's what that tube is used for, at the base of glands. And if you were to watch a tube noses, I've seen this before, every once in a while you'll see a little drip of this really grayish color water come out the end of that tip. Here's another one. This is southern giant petrel from the southern oceans off Antarctica. Okay, mating said we talk about diversity here. Right? I mean, everything is this. Birds are so incredibly diverse. Well, if we talk about mating systems, okay, the first note is monogamous. The vast majority of birds have a relationship between a male and a female, and that relationship lasts for a breeding cycle. Now, a breeding cycle could be a year in some cases, or birds that have multiple broods in a year. That monogamous relationship may be just last for one brood, and they may pair up with something else. But during that one brood, they're pretty much together. Doesn't mean that somebody might cheat once in a while, but that's much. But notice polyandry. Less than 1% of the birds do this. And polyandry means a female with many men. And here's the idea. These are red-necked phalaropes. The bird on the right-hand side is the female. You'll notice she's brightly colored, and the male is much more cryptically colored. Okay? What the female will do is mate with the male. The male, then she will go and lay her egg in his nest. He's made the nest. Then he incubates the egg and takes care of the young. She may go off and find another male and copulate with him and then have an egg in another nest. Okay? These are these phalaropes. I took these photographs at Utqiagvik, which is, you might know it as Barrow, Alaska, 300 miles north of the Arctic Circle. Female on the left, much more brightly colored, male, more cryptically colored. And then you have jacanas, okay? Again, another thing is the male is the one that incubates the eggs and cares for the young. Works pretty well for them. Okay, now I've already given this assignment out, but I want to give it out again, okay? You have some homework to do, and your homework is to go on the internet. I don't think much of the internet, but some good stuff there. And you look up the courtship display of red-capped manakin, okay? Talk about a display. So what these birds, a number of species of birds that use leks, L-E-K-S. Those are specific areas where males dance to attract females. So manakins and grouse and sage grouse have this type of thing. Think of it as a dance floor, okay? The males don't participate in nest building or incubating eggs or caring for the young. That's all on the female. But they make these display areas, keep them nice and clean and everything good. The males will be sitting in that area, clicking or singing. And when the female comes, they'll do these dances, okay? And then she'll pick the one that she thinks has the best step. Beautiful small bird. So this is a orange colored manakin. This is a female. Now, an interesting story here. I took this photograph because this is in Costa Rica. And I was a little restaurant where the lodge we were staying, And apparently this bird had flown in and hit a window. It was laying on the floor. Well, I picked it up, I put it in some, kept it warm, I put it inside my shirt, and she started to revive. Okay. And then I just put her down on the ground in a safe place and took her photograph. But but on the right-hand side, that's a greater sage grouse. That's from California. In other words, the females are coming into the display area. It's time to mate, and they're looking for the male that's going to give the best dance. Let's talk about avian migration, which is just spectacular. Now, I just want you to think for a moment about let's say you want to fly to Florida, okay? Just think of all the equipment that is needed to get that plane from, say, Logan or wherever you're calling from to Florida. You have satellites, you have radar, you have radio contact, you have ground tracking stations, you have all this kind of stuff, okay? But birds don't have that. Everything they need is in their head, okay? They have the ability to sense things, and I'll show you that. Okay, there is two different types of migration, basically. There is the parental guided. In other words, the parents teach their young ones when to migrate and where to migrate. And if you need stopover places, where are those stopover places? And then the other type is, no, the young ones are completely on their own. Okay. I did a lot of bird banding in this area up in Massachusetts, eastern Massachusetts. And what we would always find is when it got into September and October, 85 to 90% of the birds that we were catching were all hatched that year. In other words, the adults have been long gone, okay? And the young ones are on their own. So in case of, this is geese and cranes, the upper portion are sand hill cranes from Bosque del Apache National Wildlife Refuge in New Mexico. The bird on the right or in the back, that's the adult. And the one in the foreground is the young bird. The bird that was hatched, well, if I did this in January, the summer before. It's less than a year old, put it that way. Also from Bosque del Abache, at the bottom are snow geese. Notice the two in the background, they have a lot of gray in the feathers, black in their feathers. Those are birds that were hatched the prior summer. So again, they're not even a year old yet. And the other one that had the more whiter plumage, those are the adults. So the adults, the young ones are flying with the adults, and the adults are teaching their young one where to fly, when to fly, when to stop. And then you have genetically programmed. This happens to be a black Burnian warbler, one of these. They don't nest very much in Massachusetts. They typically nest further north. Some of them do out the western part of Massachusetts, but they have genetically programmed migrations. Their genetic code, which has been handed down for tens of thousands of generations, basically tell the bird which direction to fly and for how long. Of course, with the experience, if they can survive that first migration, then the birds learn from that experience as to where to go and where to stop over for food. So there are multiple aids to aid in navigation. Navigation is a big deal, okay, because you want to make sure you're migrating to the right place. Some birds like ducks and cormorants and things like that, they use visual landmarks like a coastline or the Connecticut River or the Appalachian Mountains. Those are sort of landmarks as to where I'm supposed to go. They use solar compasses to tell what direction they're going in. They have solar compasses. They can sense the magnetic field. Now, I ask a question. How many of you can sense the inclination of the magnetic field of the Earth? I suspect not many of you. They use smell to find a way back to the proper place. And some of them use infrasound, very low frequency sound, like the wind flying through the mountain passes. Okay? So birds that are in India that are going to Mongolia, they can hear the sound of the wind going through the Himalayan mountains to know which mountain pass to fly through. Let's talk about a solar compass. Okay, if it's morning and the sun is on your right-hand side, then you're flying in a northerly direction. Okay. Now you don't have to know it's 7:30 or 9:30. But if the sun is over there and it's morning, I'm headed in a northerly direction. Okay, if it's afternoon and the sun is on my right-hand side, I am flying in a southerly direction. So basically, birds have to know what time it is. Again, they don't have to know it's 7:15 versus 8:45, but they have to make this correlation between where is the sun and what time of day is it to use that solar compass. Inclination of the magnetic field. Okay, we can't do this, but a bird can. A lot of birds can. So basically, if you're standing on the south magnetic pole, the electromagnetic field comes through your feet up to your body and out your head. And if it's your north magnetic field, it goes through your head, through your body, and through your feet. And birds can sense the differences in angle of that magnetic field. This is proved beyond a doubt. They put birds in uh, within a magnetic field, and if it's springtime and the birds want to be going north, they face in that direction. Okay, but then what they do is they change the magnetic field, and it's over here. Well, the birds still want to go north. The magnetic field say no, it's over here, and the birds will change which head where they're headed. I'd like to talk briefly about mag migration feats. This to me, of all the amazing things about birds, I mean, nature in and of itself is an incredible story. There's a miracle every time you go outside. Okay, to say migration feats. Here are two birds, black-polled warbler on the left, size of a chickadee, and then the bar-tailed Godwit, about a bantam rooster type size. Okay, so here's a black-polled warbler. I've been in Alaska. I've been in Nome, Alaska. And these birds, the ones in Alaska, are traveling 12,000 miles round trip. Okay. Now here's the flight, what they have to do. So I'm in Nome, Alaska, and I took a photograph in Nome, Alaska of black-polled warblers. So that those black-polled warblers, when their internal calendar says, "Hey, buddy, okay, I know you're only 3 months old, but it's time for you to migrate. You've got to migrate now." Okay. So the bird may be early September, late August. The bird flies across Alaska, across the Yukon, across um, Alberta, Saskatchewan, Manitoba, comes into Ontario, flies down into to north to where we are in New England. That's 3,000 miles. Now there are multiple stops en route, but still 3,000 miles. And then the birds have to build up fat reserves. They can basically double their body weight with fat because they need that fuel, that fat, to fly nonstop now from New England to the north coast of South America. But they're not done. Then they go another 1,500 miles down to Bolivia, Peru, Bolivia. Then they go, when their internal calendar goes off again, it says, "What the heck are you doing in Bolivia? You're supposed to be heading back to Alaska again." And they take off, they go through Bolivia, up to Colombia, Middle America, and back to Nome, Alaska. They're not even a year old yet. Pretty good. Okay, this is white-rumped sandpiper. Notice, notice those are wings. That's not its tail. With that yellow arrow, those are where the wings are long enough that they cross over behind the bird. Okay, they're going 9,000 miles one way from north of the Arctic Circle. I've seen them in southern Argentina. Okay, and so they make many stops in transit. And those long wings, why the long wings? Because it provides more efficient flight. They can get more mileage on less fuel. Okay? And here's a white-rumped sandpiper in among a whole bunch of semi-palmated sandpipers. Notice the semi-palmated sandpipers, the wings basically just come to the end of the tail. And the one with the yellow is the white-rumped sandpiper. Okay? Northern wheat ears. This is an image from Nome, Alaska. This is male in the foreground, female in the back. Okay, there are two populations. If you go up to Hudson Bay, everything from east of Hudson Bay is going to go to the east, and all those on west of Hudson Bay are going to go to the west. Okay? Okay, so here, So the birds from western part of Canada and say Alaska, they are going to migrate across the North Bering Sea, across Russia, Peninsula, across Mongolia, across Kazakhstan and Turkestan, all the way down into, and they end up in, I've seen them in Tanzania and Kenya. Okay, so that migration is 9,320 miles one way. Okay, the other ones that are in east of, say, Hudson Bay, or generally speaking, they go east. They fly across the North Atlantic, across Greenland, into Europe, and then they overwinter in West Africa. Okay, that's 4,660 miles one way. These birds are the size of a chickadee, slightly bigger. Bobolinks, they're a member of the ictrid family, so they're in the same family with red-winged blackbirds and orioles and caciques and oropendolas. Okay, their migration is 12,500 miles. This is a bird in its basic plumage. So they're migrating from our area, a little bit further north, all the way to the southern part of Brazil, Paraguay, Bolivia, Argentina. Yeah. Arctic terns, they nest, nearest place to me, the Isles of Shoals, which are the islands right on the board. Part of them are in New Hampshire, part of them are in Maine. They breed there, and then all along the Maine coast, all up into the Canadian Maritimes, so forth like that. They put a nano tag, a locator tag, on an Arctic tern in an island in the Farnes Islands off the United Kingdom. And that records sunlight periods. And from that, scientists can deduce where this bird was. Okay. And one bird was recorded to have traveled from the time it left the nesting colony in the late summer to it returned again in the spring. It had traveled 59,650 miles. As amazing as all those feats are, this one, okay? This is bar-tailed Godwit. I photographed this thing on the road, to Teller Road in Nome, Alaska. Okay, beautiful bird. Okay, this is the female I'm showing you here. Okay, a bar-tailed Godwit, and with the band number B6, you can put on the larger birds, you could put a band that you could actually see from a distance with a telescope or binoculars. And that bird flew 8,425 miles nonstop from Western Alaska to Tasmania, the island off southern Australia. It was in flight nonstop from October 13 to October 24. The bird was aloft for 11 days. Think about the stamina of a bird like that. Yeah. And so that's quite an achievement, I think. 8,425 miles nonstop, 11 days. Okay. And then briefly on tool use, birds use tools. Okay. They're very good at it. On the left-hand side is here we go. If you've ever gone to a park or something near the ocean, you might notice there's a lot of shells, especially blue mussel shells in the parking areas and the whatever. Well, the birds will go into the intertidal area. Happens to be a herring gull in its basic plumage, winter plumage. It will grab one of these blue mussels, rip it off the rocks or something, fly up in the air, and then drop it onto the pavement to break it open. The woodpecker finch. This is a bird from Santa Cruz Island in the Galapagos Island. It probes in the holes of trees and things like that, looking for insect larvae. And what it will do, it will break off either a sharp stick or a cactus spine or something, hold it in the bill, and using that thing to probe in there to spear a larva that it pulls it out and eats it. So there's that herring gull, and there is the woodpecker finch. Burn owls, different way of using tools. It will collect up animal dung from around this is its nest hole here, and they will bring some of that animal dung into their burrow to attract dung beetles. Dung beetles come in to go to the dung, and the owls eat the beetles. Okay, tool use. This is yellow-bellied sapsucker. Okay, and it makes all these holes. Notice in the lower left-hand corner, it's making these holes in this tree in order to make the sap bleed. The sapsuckers will lap up some of that sap that's running, but it also eats the insects and spiders that are attracted to that sweet material. See this in Florida. Okay. And food storage, avian food storage, we have the gray jay on the left-hand side. These are known as camp robbers, but whenever I would take people on trips to northern New Hampshire or Maine, we'd always have a handful, a bag full of nuts and things like that. Because if we ever see one, you just put one out in your hand, they'll come and land on it. The other, and take the food. The other one is loggerhead shrike. So here is the Canada jay. It's filling its crop as part of the throat, okay? And will carry this food back and hide it. And then you have acorn woodpeckers, which are food storage. The telephone pole. This is a granary tree. This is an old telephone pole that these acorn woodpeckers have made holes, and then they will fill those holes with acorns, because some years you get lots of acorns and some years you don't. Okay, and so here's a way of storing food for a bad year. Food storage. Okay, here is a northern harrier. This is a female northern harrier. Notice where the yellow arrow is. This bird has been feeding, I think it was a dead duck. Okay, and what it does, first of all, it eats its fill, but it didn't want to waste or leave the rest of this food behind. So it has a crop, okay, that, like, think of it as a little sack inside themselves that they fill up before it goes to the stomach. So, look, food can be really scarce. You don't want to waste any. So you'll carry it with you. And you can see this is distended. It's full of duck meat or whatever that is. Okay. And shrikes, these are known as butcher birds because very often, well, they'll catch small birds or small insects, and then they impale them. Here's a bird on the left that's caught, and then the right has impaled it on a spike, either a cactus spike, a sharp stick, or in this case, a barbed wire, in order to store it. Brood parasites, different way of breeding thing. We have the cowbird and the redhead duck. So over 220 species of birds are parasitized by these warblers and flycatchers and things like that. The female lays her egg in another bird's nest for those foster parents to take care of their young. Giant cowbird parasitizes things like oropendulas. And redhead ducks, the female sometimes will lay all her eggs in her own nest. Sometimes some of her own nest and some of another nest, and some of them all in other duck's nest. So this is behavior depending on the conditions. So different ways that these brood parasites behave. So that redhead parasitizes mallards and canvasbacks and things of that nature. And then nest building. It's a tremendous diversity here. The oropendula nests on the left-hand side. And I think of cliff swallows as being masons of the sky. I mean, they go down, they take a mouthful of mud from a little puddle or something, and just like putting bricks on a wall or something, they make their own head. This is a bird from Argentina. This is a Rufous hornero, and that's its nest on a branch or on top of a fence post. It makes its nest out of mud. Okay? It gets the name hornero for oven. Looks like an oven. The cliff swallows make these extraordinary nests. Sapsuckers make holes in the trees. The male is in the nest, has just brought food for its young. The female is outside. She has food in her mouth and could give it to young. Chickadees make holes in trees. You can see if you look in the hole, there's a chickadee inside there. Yeah. Well, these are those nests of the Oropendulas on the left hand, caciques and oropendulas are closely related, and then the Baltimore Oriole to the right. This photographed it in Massachusetts right here. And birds, big birds of prey. This eagle's nest, 5 or 6 feet across, but some of them can be much, much heavier, much huge, because some pairs of eagles will use these for 10 or 20 years. Made out of sticks. And many shorebirds really don't make nests. They make just depressions in the mud. This is a piping plover, and the little tiny piping plover right next to it, they just make a depression in the sand, or just clear a little place in among gravel, and the female lays her eggs just on the ground. On the left-hand image, we have a female that's on her nest, and we have a male that's brought in a fish, a sand lance, to feed to her. And other birds make their nests out of their down. This is common eider. And here is on the right-hand image that's from Iceland. This is a farmer that's made a little pond, and he put tires and things like that on this little island, so the females will come in and make their nest in those tires just as a safe spot. The females pluck the down from underneath her breast feathers and makes their nest out of it. So she could cover it up. If she has to go feed, she could cover them over so a gull can't see the eggs, and also to keep the eggs warm. She goes to feed and comes back. Well, the farmer has given them a safe place to nest, and he comes back and collects the down for down vests and comforters and things like that. Here, gulls, sea birds that nest on cliff faces. Very, very narrow cliff faces, but they're protected from terrestrial predators. Yeah. And some of them dig these holes like kingfishers. These happen to be bank swallows. So some of the kingfishers, like belted kingfisher, those cavities that they construct could be up to 6 feet deep. Huge. Okay. And I just want to focus a few more things here. Size difference. The smallest bird in the world is on the left-hand side. This is male bee hummingbird from Cuba. Okay, so here's a bee humming. Now, we want to talk about tiny. Okay, notice the female. Okay, 0.092 ounces. Male is even smaller there. Okay, just think that you can send a first-class envelope 1 ounce. Just think of how many, if you wanted to send bee hummingbirds in the mail, you could put what, 8 or 9 of them in that envelope? 4 sheets of paper or 8 or 9 hummingbirds? Okay. Albatross, think about wingspan, 12 feet. Talk about diversity. And here's a Cory bustard. It's one of the heaviest flying birds, weighs up to 44 pounds. This is a bird from Kenya. They're also in Tanzania. So I just think this is sort of funny. If you want to make a comparison, weight comparison, talking about diversity, the world's heaviest bird is a common ostrich. The males can be up to 9 feet tall and weigh up to 300 pounds. Well, if you compare that to the smallest one, the common ostrich is 69,560 times heavier than is a bee hummingbird. Talk about diversity. Plumage differences by gender. These are both euphonias. Euphonia means beautiful of song. Here are eastern bluebirds, the female on the left-hand side. I took these in the winter, and the male on the right-hand side. Very distinctly different plumage characteristics. The female red-winged blackbird. Most people see a red-winged blackbird, beginning birds, they have no idea what it is. And the male on the right. And then difference in plumages by age. The great black-backed gull takes 4 years to get that plumage. So here is a young one on the right-hand side. And then plumage is here again by age. On the left-hand side is an adult male, common goldeneye. On the right-hand side, looks very similar to a female, but this is a young male common goldeneye. You can see the little white spot just in front at 8 o'clock from the eye. Bald eagles take 5 years to get that adult plumage. So you'll see many, many young ones looking like the one on the left. And plumage coloration. Okay, feather pigments, they are carotenoids. Okay, these are natural occurring chemicals. get red, yellow, and orange, melanins, blacks and grays, and porphyrids, pinks, and things like this. So you're getting actually different colors, like the cardinal male color, or the cormorant, or the long-eared owl. So birds get a lot of the colors from pigments and feather structure, but other comes from the structure. As the feather is formed from the feather follicle, little crystals of melanin are inserted into those feathers, and they act as prisms. So you'll get, here's a mallard duck. Notice the head is turned one way. It looks really quite black, but it turns at a different angle, and you see the distinctly green. So that black is pigment. The green is the structure of the feathers. Color morphs, you have color morphs. You have screech owls. Some of them are really gray morph and some of them are red. These are all normally occurring birds, plumages. And then Lucia, you have genetic mutations. Sometimes the genetic codes are not properly duplicated. So here is a black-capped chickadee on the left-hand side in what we would think of as normal plumage. I ran a bird banding station, and the volunteers we had there were extremely competent, very competent. And one of the rules is you cannot band a bird unless you know what it is. You don't put a band on it unless you know what it is. Well, they caught this bird and it was incredibly dark, much darker than the one you see here on the right-hand side. They had no idea what it was. They couldn't figure it out. And as soon as they let it go, they knew exactly what it was. Because as that bird flew away, it went chickadee dee dee. It was a melanistic chickadee. It was all black. Yeah. And here's a leucistic one on the right hand. So this is the reddish egret. Doesn't have the proper amount of pigment. This is red. This is red-breasted merganser. This is a female, what we think of as normal plumage. And there is the one leucistic one on the, it's just simple. It's not albino because it has coloration. It's just really deficient in how much coloration. And I'm going to end up with, this is the rarest bird by far I've ever seen. And probably you may never see one, okay? This is called a bilateral gynandromorph, okay? Rarely, genetic errors occur in animals, and we get bilateral gynandromorph. They're very, very rare. They're more common in insects. You do see it in insects. But in the case of birds, during the first cell division of a fertilized egg, the cell chromosomes fail to divide properly. The developing egg contains XW for phenomochrome and ZZ chromosome of the male. So the same bird has both male and female chromosome. When this happens, the bird develops into a bilateral gynandromorph, and that's what it is. This is the rose-breasted grosbeak on the left. That's a normal-looking female, and the normal-looking male on the right. And this is what they look like, a bilateral gynandromorph. Notice as we're looking at it, the right side of the bird is the male, the left side is female. Well, I'll just end up my conversation with a closing thought. If you've read Virgil's The Aeneid, book number 6, you will remember, by the way, Virgil was writing between 29 and 90 BC, sometime between that time period is writing. He said, Facilis descensus Averno. I remember that well from my third reading. Anyway, it says the descent into hell is easy. That's what it means. And what says Averno means literally without birds. So what Virgil was saying is hell is a place without birds. Well, that's it. I think I'm done. I went a little bit over time. Sorry for that, but
No,
that's
it's
it.
more than okay. Those are some very, very incredible facts. It does seem like we just got a question in from Jill. Do you keep a life list in terms?
No, I don't. I did for a while, and then I found it took me longer to develop a life list I'd much rather doing that. I'd rather be outside. I mean, so I've seen more than 700 species in North America, but I don't know where I am now. I don't know. And because I've traveled worldwide, I've seen a lot, but I have no idea how many. I mean, I have a general idea, but I could be off by a lot. So.
That makes
But
sense.
a life list is can be very, very helpful, especially if you're keeping a listing, say, of your community or areas around that. It's really interesting to keep a life list over the years, especially if you're year to year to see how bird populations change over time. Yeah.
That's a good point. Definitely something to consider. I guess one question I do think would be fun is, does tool use get taught, or is it something that's kind of inherent within like their genetic makeup? Like, are they able to like see that needle on the cactus and realize that that's something they can use, or do
Yeah,
they
that is
mimic?
that is an excellent question. I suspect at least some of it is learned behavior. Now, whether it was learned first, who knows? But it's very obvious well, usually you see large groups of gulls in parking lots, especially at this time of year when they're not breeding. And I suspect that somewhere along the way, somewhere far in the distant past, some bird, I don't know if they thought about it, but did it. And the other birds were watching. Well, ooh, that seems like a pretty good deal. So I think that is a wonderful question. To be quite honest with you, I don't know the answer to that. But I
Okay,
suspect that there is some cultural um, aspect to it where it's learned behavior.
cool. It's good to know. Something to look up for later then.
Yeah.
All right, I think we're definitely good on time. If we don't have any other questions. So yeah, thank you so much, Bill. And thank you everyone who joined us today. If you would like to view this program again, it has been recorded and will be posted to the library's YouTube channel within the next few days. I'll also be including the link to the video and the recap email that will be sent out soon, along with a feedback form that you can fill out. If you also enjoyed Bill's program today, there will be another one on Wednesday, March 25th at 1 p.m. that you can register for now that focuses on the wildlife of West Texas and Big Bend. But yeah, thank you again for everyone's participation, and I hope you all have a great rest of your day.
Good day. Thank you.
Thank you.